Hi, in this presentation I will briefly present the results from one of our latest research studies, addressing how regulations of safety critical software affects technical debt. The involved researchers are Therese Besker, Antonio Martini and Jan Bosch. In today's software industry, the use of safety critical software is increasing at a rapid rate. However, little is known about the relationship between safety critical regulations and the management of technical debt. We know that safety critical software must adhere to domain specific frameworks and standards. This means that these software applications are required to pass a regulatory certification process prior to being placed on the market. By interviewing in total 19 practitioners from 3 different companies, all working in different safety critical domains, implementing software according to different safety regulation standards, we found 3 major interesting findings addressing technical debt and the development of safety critical software. The first finding shows that performing technical debt refactoring tasks in safety critical software requires several additional activities and costs compared to non-safety critical software. First, we have the additional documentation. Before performing a refactoring activity, there is often an additional need to create new safety cases with new safety analysis to show that the safety critical software regulations properly adhere. There is also an extensive amount of documentation describing the source code and its dependencies to what needs to be updated after the refactoring activity. Further, after technical debt refactoring activity, the altered application commonly needs to be tested and run in a simulation or in an emulation environment. This activity is both time consuming and potentially dependent on resources from other departments as well. This activity also commonly comes with additional license costs for using required equipment and tools. Refactoring of safety critical software requires additional risk assessments due to potential time delays, since the complete refactoring process includes and is dependent on staff and resources from several other departments and not only the staff who perform the initial refactoring task. This dependency on external resources entails and reduced control over the strategic planning and the management of time. And then we have the extended test scope. Testing refactor safety critical software often requires not only testing the specific isolated refactored component, the test scope is also commonly extended to related components and subsystems. Yet another important factor refers that all technical debt activities are concerned. This implies that even minor refactoring activities could cause significant cost and extra effort, which commonly needs assistance or authorization from colleagues or managers. And then we have the final factor, which is the requirement of additional recertification or requalification activities. This process commonly involves an internal audit of the concerned components and its related components due to dependencies among them. When studying the effects of these factors, we find 3 main consequences. First, we have the need of a proactive guidelines, meaning that since the refactoring of technical debt in safety critical software requires both extra activities and cost, it is of vital importance to implement safety critical solutions as optimal as possible from the very beginning. Yet another consequence is the avoidance of refactoring activities. As a result of the mentioned consequences of performing technical debt refactoring, we see that due to those extra costs and activities, TD refactoring activities are commonly deliberately avoided, with the result of an increased amount of technical debt in the software. Further, our result also shows that practitioners often develop workaround solutions to avoid technical debt refactoring activities and thereby to avoid the associated consequences and the need for the additional activities and costs. As I earlier mentioned, TD refactoring in safety critical software is associated with several extra costs and activities and requires thereby, for example, additional budget, additional resources, additional time, and a need for a recertification or a requalification process. This infers that the overall cost equation formula for technical debt refactoring activities for safety critical software becomes more complicated and extended compared to non-safety critical software. None of the investigated companies explicitly performed a cost-benefit analysis in a structured way, comparing the benefits of performing the refactoring with the cost of it. The main reason for not conducting such analysis was described in terms of a lack of data or lack of estimates on the benefit side of the equation, both from a direct or an indirect perspective. Taken together, our results shows that the TD refactoring decisions are made with cost-based optimality conditions, rather than comparing both cost and benefit side of the equation. Okay, in the last part of this study, we focus on the software architecture. We know since before that there are different architectural structures, such as a component-based, we have the pipe and filter, we have monolithic, and we have also a layered structure. Our analysis shows that specifically the architectural structure of a safety critical software has a huge impact on the possibility and probability of performing technical debt refactoring activities. Safety critical software based on a monolithic architecture components is characterized by interconnected and interdependent components and were described as a major hindrance for TD refactoring tasks in safety critical software due to the interwoven nature of different components and resources. So, this is my last slide. In a very near future, we will invite you to participate in a workshop where we will present even more results from this study and together with you discuss the implication of this study. Really, thanks for listening. Thanks and goodbye.